Hi, welcome. In this example, we're going to be solving an inequality and then graphing its solution. The thing to remember about solving inequalities is treat them exactly like equations. The only difference is if you ever multiply the entire inequality by a negative number, you need to change the direction of the inequality symbol. First step I'm going to do is I'm going to distribute this negative 5 here. The next step is I'm going to add 30 to both sides. And I'm going to go ahead and add 8x to both sides in order to get my x's all together on one side of the equation. Now, I need to get rid of this negative 32 times x. The way to get rid of a negative 32 when I'm multiplying is to multiply it by a is to divide by negative 32. So I got rid of this multiplication by dividing. 32 divided by negative 32 is negative 1. These 32s are going to cancel. Whoops! But don't forget, I divided by a negative, so I need to flip the direction of that inequality symbol. There it is. So my result is negative 1 is greater than or equal to x, or you could write this as x is less than or equal to negative 1. They both mean the same thing. Let's graph it. So the way to graph this is, here's my number line. This is my boundary point. So I'm going to draw a circle around negative 1. And I'm going to imagine that there's this border wall here at negative 1. And I'm going to test points on the right and on the left and at the boundary. And I'm going to shade wherever the values in those areas are true. So I'm going to select first 1 to check. X equals 1. I'm going to take my original inequality here, and everywhere I see an x, I'm going to replace it with a negative 1. I'm sorry, with a positive 1. There and there. Now I'm going to crunch these numbers really quickly using my order of operations to make this happen, and I'm going to see if the resulting statement that I get is true or not. Oh, I don't know what that is off the top of my head. Handy dandy calculator to the rescue. Negative 5 times 14 is negative 70. And then I think to self, is negative 6 less than or equal to negative 70? And the answer is no. No, it is not less than negative 70. And so this section is false, and I cannot shade in that area. I'm going to check now this one, the x equals negative 1 section. So I'm going to take my original equation, and everywhere that I see an x, I'm going to replace that x with a negative 1. And once again, just like with the example above, I'm going to very quickly crunch these numbers so that I can see if my statement is true or not. All right, is 10 less than or equal to 10? Yes, yes it is. 10 is equal to 10, and so I'm going to color in the value at x equals negative 1, because on the boundary that statement is true. I have one last location to check, and I'm going to grab another sheet of paper here and just cover over this work so that I can write and we don't lose sight of the graph up here. I'm going to go ahead and check something over here on the left of x equals negative 1. I'm going to keep the number small, and I'm going to go with this negative 2. So once again, I'm going to rewrite the original inequality, but everywhere I see an x, I am going to replace it with a negative 2. Once again, I'm going to work very quickly, and I'm going to just crunch the numbers using my handy dandy calculator whenever I get stuck and can't remember how to do the multiplications. And the statement we have at the end is 18 is less than or equal to 50. That statement is true. I would much rather have the $50 than $18. And so because it's true, it means I'm going to shade in everything to the left this way toward the negative 2. And that is how we solve and graph an inequality.